The nature of modern warfare is changing at a rapid pace. Today, one of the most significant and growing threats on the battlefield comes from unmanned aerial vehicles, more commonly known as drones. These are not just the large, sophisticated aircraft seen in news reports from years past. The new danger comes from smaller, cheaper, and more numerous drones that can be deployed by the dozens or even hundreds. These devices can be used for surveillance, to guide artillery, or as weapons themselves, carrying explosives to a target with unnerving precision. Their widespread use in recent conflicts, such as those in Ukraine and the Middle East, has shown just how effective they can be, altering the strategic landscape for armies around the world. What makes these drones particularly difficult to counter is their very nature. They are often small, making them hard to detect on radar systems that were designed to spot much larger targets like airplanes or missiles. Their low cost means that an adversary can afford to lose many of them in a single attack, overwhelming traditional defense systems through sheer numbers. This is often referred to as a swarm attack. Trying to shoot them down one by one with expensive missiles is not a sustainable strategy. A single missile can cost hundreds of thousands or even millions of dollars, while the drone it destroys might only be worth a few thousand, creating a severe economic imbalance for the defender. This presents a serious challenge for modern militaries. How do you protect soldiers, vehicles, and critical infrastructure from a threat that is both cheap and numerous? Conventional air defense systems, like machine guns or missile batteries, have their limitations. Guns may struggle to hit small, fast-moving targets, and as mentioned, missiles are an economically unviable solution against a low-cost swarm. The need for a new type of defense has become urgent. Armies require a system that can react instantly, engage multiple targets quickly, and do so at a very low cost per engagement. The search for this solution has led defense innovators to look toward a technology once confined to science fiction: high-energy lasers. The problem is clear and present. The proliferation of drone technology means that even smaller non-state groups can now wield air power that was once the exclusive domain of powerful nations. This democratization of aerial threats requires a corresponding revolution in defensive capabilities. Armies can no longer rely solely on the old methods of air defense. They need a system that is not only effective, but also cost-efficient and capable of handling the high volume of targets presented by a modern drone swarm. Without such a system, forces on the ground remain vulnerable to this persistent and evolving danger from above, a danger that promises only to grow more complex in the years ahead. In the quest for an effective counter to the drone menace, high-energy lasers have emerged as a highly promising technology. Unlike conventional projectiles, a laser beam travels at the speed of light, meaning it can reach its target almost instantaneously. This eliminates the need to calculate a projectile's travel time, making it much easier to hit a small and agile target. Once the laser is locked onto a drone, it delivers a concentrated burst of thermal energy. This energy rapidly heats the surface of the drone, which can melt its structural components, fry its sensitive electronics, or even detonate its explosive payload from a safe distance. The entire process, from targeting to destruction, can take only a few seconds. The primary advantage of laser weapon systems lies in their economics and logistics. While the initial cost of developing and building a laser system is high, the cost per shot is incredibly low. Instead of firing an expensive missile, the system uses electricity to generate its beam. The cost can be as low as a few cents per engagement, a stark contrast to the millions spent on traditional interceptors. This completely changes the economic equation of drone defense, making it feasible to engage large numbers of low-cost targets. Furthermore, a laser weapon has a virtually unlimited magazine as long as it has a power source. It does not need to be reloaded with physical ammunition, simplifying battlefield logistics significantly. This capability to engage many targets in rapid succession is crucial for defeating swarm attacks. A single laser system can pivot quickly from one destroyed drone to the next, neutralizing dozens of threats in a matter of minutes. This is a feat that would be nearly impossible for a conventional missile-based system, which would quickly run out of ready-to-fire interceptors. The speed and precision of lasers mean they can create a protective dome over a designated area, systematically picking off incoming threats as they are detected. This makes them an ideal component of a layered defense network, working alongside other systems to provide comprehensive protection against a wide range of aerial dangers. The concept of directed energy weapons is not new, but recent technological advancements have finally made them practical for battlefield deployment. Engineers have overcome many of the initial hurdles related to power generation, beam focusing, and atmospheric distortion. Modern laser systems are becoming more powerful, more compact, and more rugged, capable of operating in the harsh conditions of a military environment. As this technology matures, it promises to provide armed forces with a revolutionary tool, one that can effectively and affordably address one of the most pressing tactical challenges of the 21st century and change the calculus of air defense forever. Responding to this urgent need, the Australian defence company Electro Optic Systems, or EOS, has developed a groundbreaking solution, the Apollo High Energy Laser Weapon. Unveiled in 2025, Apollo is a directed energy system specifically engineered to counter the threat of drone swarms. It is not a theoretical concept, but a market-ready weapon, with an initial sale already made to an undisclosed NATO country. The system represents the culmination of years of dedicated investment and research aimed at maturing laser technology into a reliable and powerful defensive tool. It is designed to be a cost-effective and decisive answer to the challenge posed by the widespread use of unmanned aerial systems in modern conflicts. The capabilities of the Apollo system are impressive. It is a 100 kilowatt class laser that can surge its power up to 150 kilowatts for short bursts, delivering a powerful blow to its targets. This allows it to physically destroy drones at a range of up to 3 kilometers, or about 1.86 miles. Even more remarkably, it can use a lower power beam to disable the sensitive optical sensors on a drone from as far away as 15 kilometers or over 9 miles, effectively blinding it long before it becomes a direct threat. The system is designed to be highly efficient, capable of engaging and destroying up to 20 small drones per minute, slewing its emitters across a wide arc in less than a second to acquire new targets. One of Apollo's most innovative features is its internal power supply. This integrated battery system allows it to operate completely unplugged from an external power grid. On a single charge, it has enough energy to neutralize up to 200 medium-sized drones, providing a robust defense even in remote locations or during power outages. When connected to a primary power source, such as a generator, it can fire indefinitely. This flexibility is enhanced by its modular design. The entire weapon system fits within a standard 20-foot shipping container, making it easy to transport and deploy. It can be used as a stationary defense for a military base or critical facility, or it can be mounted on a vehicle for mobile protection of moving convoys. Beyond its technical performance, the Apollo system offers significant strategic advantages. With a cost per shot estimated to be less than 10 cents, it provides an overwhelmingly positive economic advantage against cheap drones. Furthermore, the system is ITAR-free, meaning it is not subject to strict US export regulations. This makes it easier for allied nations to acquire, localize, and sustain the technology as part of their own sovereign defense capabilities, whether operating as a standalone weapon or integrated into a larger layered air defense network. Apollo provides commanders with a powerful and adaptable tool to secure the airspace and protect their forces from this pervasive modern threat. The introduction of systems like the Apollo laser marks a pivotal moment in the evolution of military technology. By providing a reliable and affordable defense against drone swarms, it helps restore the balance on a battlefield that has become increasingly tilted by low-cost aerial threats. Armies equipped with this capability can better protect their soldiers, command posts, and supply lines, ensuring they can operate effectively without the constant fear of attack from above. This technology shifts the economic burden back onto the attacker, who must now contend with a defense that can negate their numerical advantage without breaking the bank. The strategic implications are profound, potentially deterring the use of swarm tactics altogether. However, it is important to acknowledge the limitations of current laser technology. The performance of the Apollo, like all high-energy lasers, can be degraded by adverse weather conditions. Heavy rain, dense fog, snow, or even high humidity can scatter the laser's energy, reducing its effective range and power. This means that lasers are not a silver bullet, but rather one part of a comprehensive defensive strategy. They are also not designed to counter larger, faster threats like fighter jets or ballistic missiles. For these reasons, laser weapons will be most effective when integrated into a layered defense system that also includes traditional radar, guns, and missiles, with each element covering the weaknesses of the others. Despite these limitations, the advantages offered by the Apollo laser are transformative. Its ability to provide deep magazines, low cost per shot, and rapid engagement of multiple targets is precisely what is needed to counter the drone threat. Its modularity, allowing for deployment in both fixed and mobile configurations, gives commanders unprecedented flexibility in how they protect their assets. The system's internal power source further enhances this adaptability, making it suitable for a wide range of operational scenarios, from well-supplied forward operating bases to austere outposts with limited infrastructure. It represents a practical, powerful, and forward-looking application of directed energy technology. Ultimately, the Apollo high-energy laser weapon is more than just a new piece of hardware. It is a glimpse into the future of defense. As drone technology continues to proliferate and evolve, directed energy weapons will become an indispensable component of any modern military. Systems like Apollo are leading the way, moving lasers from the realm of experimental technology into the hands of soldiers on the front lines. They promise to change the dynamics of the modern battlefield, offering a new layer of protection and ensuring that armed forces can maintain their strategic edge in an increasingly complex and dangerous world. The beam of light once imagined in fiction is now a reality, and it is set to redefine the rules of war.